Alright, and in this video we look at the rest of the problems from stamp number 1, which is problem 16 to 21. Alright, let's get started. Alright, I actually don't know if I meant to give you problem number 16 right away, but hey, here it is. Alright, number 16 says, sketch the graph of y is equal to the absolute value of f of x. Alright, and so if we look at that, we think about what an absolute value does to a number. It makes everything positive. Alright, so anything below this line would flip up. Alright, so for instance, if we're looking at this graph, and let me just flip this over. Alright, if I'm looking at this graph, and let me just take this graph, see if I can sketch it real quick. Alright, I'm going to sketch that point is here. This is 1, 2, 3, 4, and 3. 1, 2, 3. -4 and 3. Alright, and it's right here. So this graph goes like this. Alright, you already knew what the graph did. I know. Alright, graph looks like that. That's the graph of function A. Alright, of f function. Alright, now, if I wanted to make it absolute value, I'm just going to flip anything that's negative up. Alright, so this piece right here now goes in this direction. Alright, everything else is already positive. Alright, and like any absolute value, it just makes a number positive. The number was already positive, it stays positive. Alright, and so that's what you do for that problem. Number 17 says write the definitions of the 6 circular functions. We should know what the 6 circular functions are, but that's sine, cosine, tangent. Alright, the one that's reciprocal of sine is cosecant, alright, and secant, and cotangent. So that's what they're asking us to. Alright, now they're giving us a point. It says that it passes. You're looking for write the definition of the 6 circular functions of an angle theta in standard position passing through the point xy. So let's just choose a point xy. Alright, xy. Alright, with r equaling the square root of x squared plus y squared. So all that is like Pythagorean theorem. Alright, we're saying, and if we find a point, what do we always draw a triangle? Using the x-axis. Alright, there's your theta. Alright, now that just means that this is x and this is y, and your hypotenuse is r. Alright, now if that's the case, then we're pretty much done with this problem. Alright, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Alright, and these are just a flip of those. R over y, R over x, and x over y. Alright, let's keep it going. Problem number 18. Alright, we got 2 stipulations here. It says if sine theta is equal to -4/5, so it's telling us that sine is negative. Alright, and cosine is greater than 0, so cosine is positive. Alright, so we can kind of figure out what quadrant we're in. Alright, we say all students take calculus, or something else that we say that won't be said, alright, on this video. Alright, so sine is negative, can't be here, can't be here. Alright, because that's where sine is negative, and where cosine is positive, so it has to be in the fourth quadrant, I draw a fourth quadrant triangle with my adjacent always on the x-axis. Alright, and then they tell us that sine is equal to negative 4/5. So this is, and this is not drawn to scale obviously, negative 4/5. Alright, we have a 3, 4, 5 triangle. Alright, and then we go from there. What are the values, what are the other values from the trig function? So we got cosine theta, tangent theta we're looking for. We're looking for cosecant theta, secant theta, and cotangent theta. Alright, and so let's give it to them. Alright, that's 3/5. Alright, that's negative 4/5. Alright, cosecant is going to be negative 5/4, the flip of sine. This is 5/3, and this is negative 5/4. Done. Alright, number 19. Alright, another problem where we are, and it's no calculator. You notice we haven't pulled the calculator out yet. Alright, another problem where we are using that all students take calculus. Alright, now remember, this is sine, but it's also cosecant. And this one is what? Cosine, but it's also secant. And this one's tangent, but it's also what? Cotangent. Alright, and that's all. Alright, so let's go. Alright, A, I'm just move this. You can look at your paper. Alright, where sine is less than 0, so where sine is, greater than 0 is positive, and where tangent is negative. Alright, so where sine is positive would be here and here. Alright, here we go. Would be here and here. That's where sine would be positive. But where tangent is negative, well, tangent is negative here and here, so it must be, ding, 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 quadrant 2. Alright. Again, where cosine is less than, so negative. Alright, and where tangent is positive. Tangent is positive. Alright, so let's think about it. Take cash. Alright, where cosine is negative would be over on this side, but where tangent is positive would be right there. Alright, so that one's quad 3. Alright, and then the last one. Alright, where secant is greater than 0, so where secant is positive is the same place where cosine is positive. Alright, and where else? And where cosecant is negative. Alright, it says less than 0, so that's where sine is negative. Alright, so let's do that. Alright, all take cash. Alright, so where's that true? Where's cosine positive? Well, cosine is positive here and here. But where's sine negative? Well, sine is negative here and here, so it must be fourth quadrant. All right, number 20, convert to radian measures. All right, and so we need to remember that when we're going from degrees to radians, all right, we just want to multiply, all right, by pi over 180 degrees. All right, and so let's do that. All right, so we go 40 times pi over 180. All right, that gives us 40 pi over 180. All right, and at that point, I mean, I know it's not a, you could just keep reducing. If it says it's a non-calculator problem, you want to keep reducing. All right, but you end up with 2 pi over 9 if you reduce it. All right, it says leave it in its lowest terms. All right, the next one, 165. We want to go times pi over 180. Again, all right, that's 165 pi over 180. All right, I know it's divisible by 5. You can go from there if you want. All right, this gives me what, 33 pi over what is that, 36. All right, and then I see both of them are divisible by 3, so that's 11 pi over 12. All right, and that's your final answers. All right, for number 21. And for some reason, this problem gets a lot of people, all right, when they're going through the final exam review packet. But it shouldn't, everything is there for you. It's telling you everything you need. All right, so let's look at this closely. All right, it tells you that, they give you a point. They tell you that this point is at 1, 0. All right, which lets you know the radius. All right, lets you know the radius is 1. All right, so now that you can see, now that you know that the radius is 1, and I'm just going to redraw this. All right, we know that the radius is 1, and we know some point B is 0.8, 0.6. They tell us that. All right, now think about everything that we've done up to this point. It's a right triangle, so we're drawing a triangle. Am I going to use my y-axis or x-axis to draw the triangle? All right, always my x, theta. All right, now this is 0.8 and this is 0.6. All right, so then get the values that they want. They want sine theta. All right, sine theta is opposite, 0.6 over hypotenuse. All right, cosine is 0.8 over 1, which is 0.8. And tangent, all right, tangent is 0.6 over 0.8, which is like 6/8, which is like 3/4. All right, and we're done. Those are your answers. That's it.